So in part 4, we're talking about this shape class hierarchy slash interface relationship. We have an I-shape interface that defines the following. It's just properties: num size, area, and perimeter, all of which are read-only. I tweaked something on that too. I've also said that anything that is an I-shape has to implement I-equatable and I-comparable. Okay, so let's define I-shape here. If I do this, is this readable? So to implement the interface I-shape, we have to provide meaning for these properties. We have to provide an implementation. So I'm going to create these 3 properties: int num size. This is a little tricky to me, or like a little confusing. This, I believe, this is the way in an interface you say the thing has to be a property, but it's not actually writing the getter and the setter, even though it's the exact same syntax. We also want to have a public double area. Oh, hang on. We said, hang on. We said that this is read only. So I'm actually going to try this thing here where I want to be able to set the number of sides, but only when you initialize the object. And init is a special way of saying it's only settable when you initialize the object, when you first instantiate the object. So I'm going to put that there. For area, that's read only, so I just need a getter. And for perimeter, sorry, I missed the word double. It's also only gettable. We're going to always compute the area and perimeter. You can't ever set it. It's determined by the sides and the kind of object that it is. Now, the other thing that I'm saying up here is that I want to require actually, let me come back to that. So let's try one of these. Let's try rectangle, just for these 3. So in a rectangle, we want to say that a rectangle implements I-shape. What's the syntax for implementing an interface? That's right. Just remember, it's something that you have. It's a biology joke. Thank you. Thank you. I do what I can. What's up, Caleb? You should spell it correctly because it will work a lot better if you spell it correctly. That's right, isn't it? Now I'm doubting everything. Yep. Okay. Oh, after the A. This is an I-shape. Now, if when Visual Studio is working, Visual Studio Code, it'll tell us the errors that we made. I'm not getting it right now, so I'm just going to have to do it correctly, which I know. I've said that I implement I-shape, but I don't, because I didn't put in the 3 things that I-shapes must have. If you get the red squiggles, do you get the red squiggles? Then you could hover over it and say, quick fix, implement interface. I don't really know why I'm not getting that, and I kind of want to. So I'm going to close and restart. Let's see. No, let me send those back. I will send those today. Remind me if I don't. Sorry about that. Still not getting that error. I wonder if it's because it hasn't built yet. I know that I need a property here that is an int num size. that is gettable and settable only when the thing is initialized. And this is a rectangle, and I actually know the correct value for that right there. Yeah, it's 4. So I think this would be a really smart way of saying, when you create a rectangle, we're going to set the number of sides. Because all eye shapes have a number of sides, but it's actually locked in based on what the class is. We will also have a public double area, and this area is read-only. It's computed, so it needs a getter. And it will also need, I want to make sure this runs, so I'm going to return 0.0. This is clearly not correct. Yeah. And I want to do the same kind of thing here for a public double perimeter, where we have a getter. And I'll, in the same place here, just return a double, placeholder double. If I come down here to actually, can I say .NET Build -- project shapes and only build the shape project? Apparently not. I'm sure there's a way of doing that. I just don't know the way. Okay. Rectangle implements eye shape. So now we have the 3 properties that we have to implement to be an eye shape. I also want to have length and width. I don't know. It doesn't matter for how it works. I kind of want to put the distinctive properties here, though. So I want to have a property double length and a public double width as well. So those are the 2 things that are actually distinctive about a rectangle. You could do some math here. What's the area of a rectangle? So if we return length times width, blam, we're done with the logic there. For what it's worth, if you have a property that is a read-only computed property that has this little logic, it's a multiplication. You remember there's a shorthand for this. You can have this arrow function and just say the thing that comes after return that, and you don't need all of this. So that one line is exactly equivalent to what those 5 lines that I had. And for something like this that it's so small, it to me feels better to do it this way. Yeah. But you can do it either way. It doesn't matter. You like which way? This way? We could almost probably do the same thing with perimeter. Do you know the area for the formula for perimeter of a rectangle? Right. So width and a length and a width and a length. So that would be 2 times, you could do it several ways, right? Length plus width. If I put them in parentheses and add first, right? That's the same, right? I think that's it. Dylan's like, no, you have to distribute that too. Okay. So I want to say, I think that eye shape, if you're an eye shape, you also are eye comparable in eye shape. let's see. Thinking about that right. Sorry, I worked all this out ahead of time, and now I don't remember what I did. Well, let's work on it. Because is it because I don't know the
Side.
but but I can implement it here, can I? I can say, well, I really need the help. Um, this is what it should look like. This, if y'all are getting VS Code's help, then you're going to do better than me. That method right there is what I need. And I'm thinking if I put in here that I have a public actually, maybe I'm wrong. Maybe public int compared to, and I compare it to this other I shape. So what need to be able to, for now, let me return 0. Does that build? I think I gotta reference this. Yeah, okay, this is what I was wanting to go to. Okay. You think this is going to break, Tristan? So what I want to say is that if you're an I shape, you also have to provide definitions of I comparable and I equatable. What I wanted to do was write compare to in I shape, but it wouldn't let me do that because I actually know how to do it in I shape. I can't do equals until I'm down into the actual classes. Okay, so I just needed a refresh. I'm going to switch back to my other one, and then we're going to develop this. So the compare to method takes in another I shape, and it says, is this guy, imagine we have two rectangles, does this one come before this one if we were to put it in order? Or does the second one, the other one, come before the current one? Or do they come in the same spot? So when we implement comparable, I comparable, which is just the compare to method, is the only method we have to do, then we can sort our things. We can compare them to each other. Does that make sense? So the interface I comparable, which they say it's generic in I shape, so that we know the class, the data type of the other one that gets passed in. So with compare to, we want to be able to compare this shape to any other shape. The way that compare to works is a little weird, and let's just look up the documentation. This one. So I'm going to read it the way they say it. All right, so again, we're creating a type-specific comparison method for ordering or sorting instances. So what does it mean to order two rectangles? And I'm saying, me, the person who's in charge, is saying you order them based on their area. A smaller shape, a smaller in area shape, comes before one that's larger. Okay, so that's a little bit arbitrary, but that's what we're going to do. The way that this works, yeah, this is what I want to see, this table. If you return a negative number, then the object precedes the object specified by the other one that you pass in. So here, you're always in an object and you're comparing it to another one. Okay, so you've got this object with the this keyword and then the other object. If this object comes before the other object, then you should return a negative number. It doesn't matter what negative number you do. If this object comes after this object, then you return a positive number. And if this object comes at the same spot as this object, they're like the same in that sense, then you return a 0. So it really just means you need to have three different things that, like really possibilities that you return, and the convention that Microsoft adopted was negative, positive, and 0. So we would want to say something, I'm going to be really long about this. We could say if this dot area is less than other dot area, then I would want to return what? A negative number, a positive number, or a 0. I like this nod. I think it's negative. This object precedes the object specified by the compare to method in the sort order. And then you'd have to say, maybe else, you don't have to have the else. Else, if this dot area is greater than the other dot area, that makes sense? So the object that you're calling this on is actually larger, then you need to return a positive number. Otherwise, which the only way this can happen is if the areas are equal. Does that make sense? Then you return the 0, which I actually have down here. So I think this is the essence, the idea of how you could do this. But it's not the way we should do it. Does this make sense? I'm trying to be really verbose. So by doing this, we have told the whole .NET system, if you ever need to sort eye shapes, you can sort them, because the sort is just going to call compare to. And if it gets a negative number, then it's going to know, okay, they're like basically already in the right order relative to each other. If it's a positive number, it'll have to move them around. And if they're 0, it also won't have to do any work because they're the same. That's what we need to do sorting, is to be able to compare anything to anything else. And this allows us to do this now in a way that's specific to our type. That's the point of iComparable, is we're giving our custom class the ability to be sorted and ordered based on a logic that we define. I think there's a much cleaner way of doing this. If you think about it, if we're comparing areas, then we're comparing doubles, because areas are doubles. Does .NET know how to compare doubles? Yeah, like it already knows how to compare all of the built-in classes that Microsoft wrote, because those are the built-in ones. So it'd actually be simplest to just say return this dot area dot compare to this dot area, yeah, other dot area. I believe that will work, and it does the exact same thing that we had. We're just in this case, you don't really need the this. I'm reusing the built-in definition of compare to that Microsoft wrote for doubles. And then I don't have to re-express all this logic. And I feel like for most of the time, when you are doing comparison, you end up falling back on a comparison definition that some other class wrote, whether it was alphabetical or some numeric thing. Okay, questions on this? Yeah. So initially we've got I shape, and then these are the three properties that all I shapes have to have. And then I've additionally said that the I shape interface, or really I'm saying if you implement the I shape interface, you must also implement I comparable in I shape. Are you getting that too? Oh, okay, okay. So yeah, you should probably do this. You could say if other equals null. I don't know. I would probably throw a new null reference exception. Does that work for y'all? I am not getting autocomplete, and it is making. You should probably spell other correctly. Good call. So you see, I'm essentially saying, hey, type expected. Where's that? Oh, I'll put a comma without. Okay. So we're checking here to make sure that other isn't null before we say area dot or other dot before we dot into it. So this would be safer. But honestly, what's it going to do if we do that? It's going to throw a null reference exception, which is the same thing that we did. So, like, what's the point? I don't know. Now we're in control. Mm-hmm. So that's the essence of compare to, and this is how to implement these three properties in Rectangle. Okay. The other definition, the other interface that's a system interface that .NET provides is the I equatable, which is also over here, and this is the generic one that's I equatable in T, which is kind of like typed. So if you come down here, you'll see what does it mean for some class to implement I equatable in itself. Like this is, you put the generic parameter. The generic parameter is the name of the type that you're in. When you do that, you are saying that you will implement a public bool equals person question marks. This is the name of your class, other. Okay? So this example, let's see if we can get this. It says other is not null, which is, that's kind of what we did in throwing the exception. You make sure the other's not null. And it says the other dot national ID equals national ID, which would be this national ID. So what does it mean for two objects to be equal to each other? By default, when we don't do anything, we inherit the equals from object, and it does reference equality, meaning are these two things at the same spot in memory? If you had, in this example, two person objects that both had a national ID of 3, which would be an amazing social security number to have. It's like all zeros and then a 3 at the end. Although it might be hackable. I don't know. I'm pretty sure that's not a legal social security number. But if they both did have the exact same social security number, then you would say, no, these two are equal. Even if I've got 4 copies in memory, they're the same person. So what does it mean to be the same rectangle? Can somebody say that in English? Does it mean you have the same area?
All the sides are the same length.
All the sides are the same length as the other. Each of their sides. So that sounds like it has to be a square. Length equals width.
No. All the sides of one square are equal to the sides of the other square.
So
So it's like all the lengths in one square are the same as the lengths in the other. All the width in the one square is the same as the other.
So if I have a 4 on 1, that's definitely the same as another rectangle 4 by. What about this one? 1 by. Those the same rectangles? You could
Kind
argue.
of. There is a bit of translation there of like rotation.
Right. I'm saying because I'm the boss that yes, they are. So our definition, we're not going to, it doesn't matter whether it's the lengths are equal to the lengths and the widths are equal to the widths, or lengths equals widths and widths equal lengths. So kind of like the order doesn't matter. All right, so first I'm going to say that I shape, all I shapes implement I equatable in I shape. When I do that, I should get a new error saying, hey, you don't implement I equatable in I shape. You need an equals method. And that equals method should be public bool equals. Oh, let's see. I was checking this. We have to override it too because we already get one from object. And what we take in is an I shape question mark that I'm going to call other to remind me that it's the other one. Okay, so this one is bool, so we're going to return true or false. We could do it the clever way like Microsoft did, or we do need override there. Otherwise, it will, what they call hide the one that's inherited, and we want to explicitly override. This is what it means to run equals.
Mine's giving an error.
What's it saying?
Rectangle equals I shape. No suitable method found to override.
Do you get that too, guys?
Yeah. And I didn't need to override with. Throws no errors.
This is the problem you predicted? Oh. I think, let's see. But we should be able, well, should we? It really doesn't make any sense to compare two. Does it make sense to compare a rectangle to a triangle to see if they're equal? Like the first thing we're going to do here would need to be to say, do these two things have the same class? If they don't have the same class, the same data type, then they definitely aren't equal. The first thing we need to do is to say, like, if other, is null? Sorry, I need parentheses. And I don't know, this is a question I want to ask ChatGPT, I guess. I don't know if equals equals null and is null is different. I think they must be the same, but in the .NET way, they used is not null. I don't know. For safety, right? If the other object is null, then it's definitely not equal to whatever this object is, because this object exists. And that's really just like an error case. If the other is not a rectangle, I don't need that, then it's also return false, yeah? Like if I have a rectangle and a triangle, and I'm trying to say are they equal, in our world, that can never be the case. Yes. Hmm. Okay, thank you. Yeah, so I wasn't making us go here, but we've learned this before. Notice this is different. You can override equals, and you can also override the operator equal equal. And you could then give them different definitions. That would be really weird if those you had different definitions of dot equals and the equals equals operator. You see in their example here, they just fall back on dot equals. But there might be a situation, I can't imagine it, maybe ChatGPT could, as to why you would not have equals equals and dot equals be the same thing. But apparently then, because those are two different things, is cannot be overridden, equals equals can. I don't know, that almost reads better English, doesn't it? And I think it's pretty equivalent for what we're doing because we're not overriding equals equals. Okay, so then finally, when we get here, what's our actual test? This is the only logic here. If this dot length equals equals other dot length, oh, look at it. Why don't I have a length here?
Because it's eye-shaped.
So we haven't said that you have a rectangle here. We've just given it a shape. So let's say here, let's have a rectangle. Rectangle? I'm going to be really specific. I'm going to call this the other rectangle that's equal to other as a rectangle. Isn't that's a thing, right? And now that I've kind of converted it to a rectangle, other rectangle will have a length. We have to do the other side of this, right? We have to also say that width is equal to the other rectangle, not width. If that is the case, that the lengths are equal to each other and the widths are equal to each other, then I could return true, but I'm not done. You see what? This is a safe thing to do now because the only way to get here is to get past this. And yes, Cecily? Here. You're right. Yeah. And let's see. But we know it's not null because we already tested it. Wait, that was a warning or an error? I'm sorry, I'm like flying blind here because my VS Code isn't showing me errors in real life, in real time.
There's only one equal on the second.
Oh, thank you. That's going to go badly.
No, something was causing an error on my end.
Yep. Okay, so if the lengths are equal to each other and the widths are, then that's true. The other case would be if this length equals the other's width and this width equals the other's length, isn't that right? Then I could return true. And then at the very end here, now I can return false. Because if you get through all that, the only way that you get to the bottom is the lengths and widths weren't ever matching. So I think that's the right logic. And because I can't build this, it's hard to test. It almost is, to me, worthwhile to which way?
You can just compare their perimeter average.
Is it the case that if they have the same perimeter and the same area, that they're definitely the same rectangle?
When you also think about like some weirdly specific triangle that has the exact same perimeter, exact same area, rectangle.
Mm-hmm. The think about that. You would do that in. They passed the test. Okay. Hmm. Hmm. Okay, that may be a mathematical fact then.
Well, if their perimeters.
What is? That's. Oh, there's no. Yeah, I'm not overriding equals in. Hmm. Their areas are going to be different, even though the perimeter.
When you multiply the areas like x and y, so it can
Oh,
only
wait.
have one.
No, the 3 and 4 will add up to 7, 14, versus, isn't it 2 and 6 would be 8, 16? You're right, you did the they have the same area in the setup you had, but they have different perimeters. But in your solution, you have to do all that math to figure it out. In my solution, you just do some comparisons.
Calculate them in the pretty simple way.
But you don't calculate them until you call the property. So every time you call the property, it's going to do the math. Now, on the whole, we don't care about doing one multiplication and one addition. Like, that is trivial amount of computation. So that is an elegant solution. Yeah. I don't think you're doing it right, bro. Wait, you. Okay, so I see what I'm doing wrong, and I see what. I'm kind of tempted to. Okay, so by default, the override version of equals would take in the exact same class as we're in, which is rectangle. But I'm taking in any other shape. So let's see. Is there any use in that? No, there's no use in that. So now I think I'm going to change it. Tristan, don't hate me. Since there's no point in, I don't know. Like what I was trying to do is say, if every single thing that is an I shape needs to be equatable, then instead of, like I can force that by putting I equatable here. The thing is, the definition of I equatable that I'm going to choose, the definition of equals, will always say, but you have to be the exact same subclass. So why not then, like I could see how it might be cleaner to say that rectangle also implements I equatable. Maybe this, we could do this, I equatable in rectangle. Yeah, let's do this too. This will be fun. QU. So I'm saying it is an I shape, and it's I equatable in rectangle. So if it's I equatable in rectangle, then I would need to say public bool equals public. I need override. Override bool equals rectangle question mark other. If VS Code was working, it should have just said you need to add this method. So you see how these are like really, really similar? But I can imagine how if I were using this, I wouldn't know that I needed to pass in. Would that work? Because I didn't override it, it would be, that'd be confusing, wouldn't it?
Still getting a no suitable method.
This?
Yeah.
Did you add this I equatable in
Yeah.
rectangle?
I equatable. I need to
Is
like,
it because of, what does it say? Can it not?
flip it over?
It's rectangle. Here's a class. I want to. Actually, no, I would switch this around and say I would do it this way. Hang on. So, why is it so mad at me? What's this? Oh, I missed that. Curly. Okay, so look, this is to me, if you have two rectangles, what does it mean if they're equal to each other? This definition that I wrote out. So I'm going to pull this out of the equals in I shape and put it in equals in rectangle. You see what I did? I just pulled out that definition from down here. And then in the equals method on I shape, the equals method that takes an I shape, I want to return the other one, passing in the other rectangle as the other rectangle. That's probably a cleaner way of making it so that I can do equals on both. You see, equals if I take in a rectangle, or equals if I take in an I shape. But now I have even more duplication, it feels like. So now I think I like my original design better. So maybe I knew what I was doing when I designed that. I like the idea of when you're designing a class hierarchy saying, hey, anybody who implements this interface or implements this subclass as this has to provide this functionality because I want to be able to use it like this. And I thought this would provide that. And now I'm doubting all that. So and this passes the test, doesn't it? I get the test probably calls this version, right? The test calls the. Did the other one break the test then because it was the wrong type? I changed this to say other, and then all these are others. So basically, if you are a rectangle and you want to compare two rectangles, this is the method you would call. If you're an I shape, you get passed in here, and I basically to check that you're not. I guess it probably needs something like this to say if other is null, return false. What's your rectangle dot equal? No suitable method found to override. That's what y'all are getting.
Removing override.
Oh. Okay, it's my bad. I got these confused. Okay. If you're I equatable in person, it means you're providing an equals method that just takes in another object that's the same type as you. The equals that you get from object takes in object question mark, which is most general. That means, right, you see what I mean? Like it's just taking in an object. It could be anything. This one, it has to be a person. So this one is not overridable. So if you wanted to be like super, super cool, which we don't, but I'm going to show you, there's also an I equatable. Q equatable that's not generic. And if you implement I equatable, then you also have to override equals, but that version of equals doesn't take in a rectangle, it takes in an object, obj. And now this one is override. And now if you, on any rectangle, were to say, hey, is this dot equals to any other object, it would run this code. And that's the one so that matches the signature of the equals that we get from the object. What I get? Using generic I equatable t requires one object. What's that? Is it not? Oh, is it not I? Okay, that's something else. Okay, hang on. I don't think it's not that. Yeah, that I equatable only works in generic. I'm going to put this in, but I won't require you to do this. If obj is really, if it's rectangle, if it's not rectangle, then we return false, and then otherwise we return equals, passing in obj as rectangle. So I'm essentially like converting obj to a rectangle, calling this. If they're not the same, if it's not a rectangle, then it's definitely not equal. And now by jumping through all these hoops, thanks for hanging with me, we could now create a rectangle. Does this have? And say if r dot equals s, I really need to pass something in here. So I'm going to say this is a length equal to 2 and a width equal to 5. So those two should be equal, right? There's two rectangles. They're both 2 and 5. Actually, you see it? This is very unsatisfying. It prints out r equals s. And that's because we checked it as a rectangle, not as just an object in memory. So to check this, I'm going to change this to 5 and 2 and rebuild this, rerun this. And now it should still say they're equal, even though the length and width are different, but they're some combination. Okay. So what I'm saying here is that each of these is also I equatable in their own class. Do you have questions on this? So what you're going to add this compare to and this equals these two equals methods to each of them.
12 errors when I try and do .NET Build.
Oh, that's cool.
Finally get it built to work.
It does feel good when .NET Build works. On the whole, most of these it's because all the things have to exist, all the methods and classes. Do you have questions on this structs part? That's a pretty significant thing to not work.
Have it. It's giving cannot convert from interface. Trouble. Type name line segment doesn't exist in the type segment.
Yeah, that's the okay. So go into unit tests. That's the mistake. Look up to a Control F, Command F. Look up line segment dot line segment. Yeah.
Yeah.
And remove the first line segment dot from the beginning. And that's on all of those that were like that. They used to be in a namespace and now they're accessible. Does that make, so you replace that? That's what I'll send out, but you can do a find replace and remove all the line segment dot line segments with just line segment. I think it has to be capital L and capital S. It's not the little L. They were called, remember this, line segment dot line segment like this. Okay, questions about the line segment stuff? Position? How about the shape stuff? Can we put words on the questions? Yeah. Is what? Is,
Other
hmm. Hmm. I don't know. I can look at that one on one. I'm less concerned about warnings.
you cannot convert.
So the interfaces, Chuck Norris, right, should be colon ithrowable. Do you have that? And then it would have to implement all the stuff that implements.
Here we go.
I did a weird thing here. Just when you print this out, you see it's start point, space, comma, space, endpoint. Feels like a lot of spaces. I wish that I had an arrow symbol. I think I would like better, but I went with comma. That feels like a mistake.
Building unit test has succeeded with one warning.
That's good.
So now I can actually.
Now you know how broken it is. Other questions?
Can you go?
Mm-hmm.
Oh, it's.
Mm-hmm. So really, yeah, probably no. if I were going to reorder these now, to me it makes sense that it should probably go in this order, where you can say dot equals and pass in a general object. It could be anything. And I confirm, hey, is this other object a rectangle? If it is not, then it's definitely false. If it is, then I'm going to call this version of equals that takes in a rectangle. If you call equals with any I shape, I guess I probably need this same test here, don't I? If it's not null and it's not a rectangle, then we will cast it to a rectangle and run this. So I really have just given it so that you can put in other object, more general class types.
Okay, so something in the instruction seems to be where it says toString return emoji, but in the unit tests it's saying toString returns the name.
Let's see, what did I do? I have a slight memory of this. Are my tests wrong?
Well, if you see right here, we have assert r equal paper and p toString, whereas so toString should return paper is what it's at.
On which one?
On interface test. Which, as you can see here, method string to string return emoji tests.
Yeah, which one do you think is right? Do you want to change the test or change the unit test or change the Google Doc?
I'm not the one who gets to make that call.
Yeah, I'm trying to be less painful to y'all. I'm sorry about that, guys. How'd you do that? Did you just change it to return the name? I think I remember at one point in the past I made the inheritance ones to string do the emoji and the interface ones do the name, just so that y'all would have to like do extra work or something, like just, but apparently I changed this here. So I say we change this Google Doc to match the unit test, so we'd have to change that. So, right, you with me here? Look at this. I'm going to say for the interfaces only. This is so that the unit test already do this. When you make something to string, instead of returning the emoji, you return the name. Okay? So this paper should return the name into string. Rock onto string should return name. Scissors should return name. Chuck Norris should return name. Because apparently that's what's in the unit test. I'm sorry about that. What's up? Okay. Let's, when's this due? At midnight. Let's take another 24 hours on that. Is that feasible? End of Friday. I'm sorry, I didn't mean to make it so complicated. I'm hoping that you're able to learn some stuff about objects and interfaces by doing this, because these really are the tools that we're going to use as we go forward. So hack on this. Let me know what questions you have. You can ask them on Discord or email or stop by. Make sure that you push your code to your repo, because that's what I'll be grading. Make sure you put the URL to your repo in Canvas. I think I will be assigning a reading assignment from the next chapter for Tuesday. We're going to kind of shift gears and jump into data structures and start learning about lists. So be on the lookout for that participation activity reading thing in the SciBook. I will be grading the 3 or 4 things that I have for your midterm. Yes.